In this lesson, we'll focus on the 1-2 punch of test-driven development. Write tests, then refactor. We'll practice this by building our first game. In order to play a game correctly, though, you need two things. An objective, which is how to win or lose the game, and a set of rules. These are what you can and cannot do. Building software works the same way. Instead of calling it a game, we'd call it a service or feature, but you still need to know the same two things. The objective, aka purpose, which is the why and the what of the feature. Why are we building this, and what do we hope to accomplish? We also need the rules, or as we call it, the acceptance criteria or specifications. This is what the feature should and should not do. These sound a whole lot like scenarios and tests, right? That's because they are. Once you have these two things, you now know what you're building, why you're building it, and how to test it. These specifications or specs will drive how you build it. So here's the game. It's called Change for $1. The objective is to get enough change in coins to equal exactly $1. So, you need to create a program that asks the user to enter quantities for the following coins: pennies, nickels, dimes, and quarters. With those inputs, your program should then sum up all coins for a grand total. If the total is exactly $1, they win. If the total is over, they lose, and tell them by how much. If the total is under, they also lose, and then tell them by how much. We'll start by creating the Chapter 3 branch. With master or main selected, click branch, and then Chapter 3. Switch over to PyCharm and we'll create the Chapter 3 directory. Then within Chapter 3, we'll create a test coins.py file. Alright, let's get to writing our specs first. We need a function to calculate n number of pennies, nickels, dimes, and quarters. That sounds like 4 separate tests to me. We'll import PyTest, write the specs, and then mark each one as failing so we don't forget. We can just copy the pennies function for the nickels and the dimes and quarters. So instead of pennies, we have nickels, dimes, and the last one is quarters. From there, we then have to check if they won or not. Let's write the specs for when they win, when they go over, and when they go under. And we'll just write these specs or tests under our test sum quarters. Perfect. Now that we've spec'd out the core behaviors in test form, that gives us a better picture as to what we need to create. From the top, we can start writing code to satisfy the tests. Let's start with test sum pennies. Pennies are worth 1 cent. If we had 50 of them, we would have 50 cents. Wow, groundbreaking stuff. The real question is, how do we calculate this with the user's input? If you remember from the previous chapters, the input function asks the user for input and then returns that as a string. So even if they entered a number like 10, input would return a string of 10. We can't use the input function in our tests because tests are not programs. So we'll mock the input. user input is equal to 10. Now we need to convert it to an integer so we can then perform our calculations and assert the output. Pennies is equal to the int version of user input. Then assert that pennies is equal to 10. Run the test, and it passes. That means that our logic works as expected with this input and output. With the logic in place, we will now refactor the logic into a function that can be used over and over again. Refactoring is restructuring the source code of an application or piece of software so as to improve operation without altering functionality. Goodness, that was a mouthful. To summarize, refactoring is restructuring code to optimize it without changing the core behavior. Under Chapter 3, create a coins.py file. Then we're going to copy the test_sum_pennies function and paste it into coins.py. Change the name of the function because it's not a test. SumPennies is actually a pretty good name for it though, so we'll leave it like that. Then replace assert with return because, again, it's not a test, but we also want to return the sum from this calculation. So we'll get rid of the assert line here, and instead we just need to return pennies. The last thing we need to do in this function is to allow it to receive user input. We still have the mocked user input on line 2. We can solve this by moving the user input variable into the function signature so it becomes a parameter. The function signature is what is on line 1. We've defined a new function, give it a name, and then also provide a parameter list. This whole thing here is called the function signature. All right, so let's use user input. Let's put it in here instead, and then get rid of this line on line 2. That looks so much better. Now we can update our test. Back in our test file, we want test_sum_pennies to use and test our newly refactored function. Let's import SumPennies from the coins module and then put it in the test. Below import PyTest, we'll say from chapters, chapter3.coins, import SumPennies. Then replace these first 2 lines in the test with total equals SumPennies. And let's have the user input be 50. That means we also need to change this because pennies no longer exists in the function. It's now called total. And we don't expect 10, we expect 50. And look at that. The test is complete. In the previous chapters, we created scenarios first and then turned those into specifications. But in this chapter, we created the specs first, like test_sum_pennies and all the way down. Our specs did feel like scenarios though, right? Let's reverse engineer this test into a scenario. The feature would be change for $1. The scenario, calculate the sum of pennies. Then with Gherkin syntax, given the input is 50 pennies, then the sum should be 50. This style of describing behaviors with examples is part of an approach called behavior-driven development, or BDD. BDD is all about collaboration and understanding for everyone on the team, including people that aren't software engineers like product managers or UX designers. As you've seen, we do this by defining features and scenarios and providing examples, just like we have been doing by using given when then. Once everyone understands the feature and scenarios and agrees on the specs and examples, then you can turn them into tests. This sounds darn familiar to TDD, right? Where we create scenarios and understanding first, and then define specs and automated tests second. So what is the difference between BDD and TDD? The biggest difference between BDD and TDD is that BDD is for everyone on the team to collaborate and understand the feature at a high level. TDD is for engineers to collaborate and understand how to build the feature at a low level. So, if you are working with others, especially non-programmers, you should start with BDD, which will feed into TDD. If you are by yourself or only working with other programmers, you can probably just stick with TDD. When in doubt, always start with BDD because we define everything using plain English instead of programming. And, like I said, BDD will feed into TDD anyway. We'll end this lesson with challenge 1. I will provide a scenario, and you need to write the logic in the test first and then refactor, just like we did with the pennies function. The scenario is to calculate the sum of nickels. Given the input is 5 nickels, then the sum should be 25.